Thank you for that kind and wonderful introduction. What a wonderful day to all. I am Dr. Daniel Dasig, Jr., Associate Professor of Graduate Studies of College of Science and Computer Studies of De La Salle University des Marinas, Philippines. I am also an industry practitioner for 11 years now. I have been working for a decade in a Canadian telecommunications software development team, application development and support, and the change management team. At the outset, I would like to congratulate the organizing team of the International Conference on Recent Trends in Internet of Things and Blockchain. The Department of Computer Science and Engineering of GIET University, Gunupur, India. Today, I am delighted to share another ramification of the fourth industrial revolution to the faces of business and industry's landscapes. Thus, you will get an initial idea of the extensive use cases of blockchain and the huge potential this technology is bringing to the world. I will be sharing the blockchain-based shared services, a technology roadmap for a smart industry. My presentation has focused on four building blocks of blockchain and putting an effort forward toward implementing blockchain-based shared services for a smart industry. My talk will cover the rudimentaries of blockchain, shared services, use cases of blockchain and shared services, and finally, the Internet of Things technology roadmap. To start with, let's define blockchain. What is blockchain? A blockchain is an immutable time-stamped series record of data that is distributed and managed by a cluster of computers. A blockchain is a decentralized, distributed, and oftentimes public, digital ledger that is used to record transactions across many computers so that any involved record cannot be altered retroactively without the alteration of all subsequent blocks. A blockchain is the structure of data that represents a financial ledger entry or a record of a transaction. Each transaction is digitally signed to ensure its authenticity and that no one tampers with it, so the ledger itself and the existing transactions within it are assumed to be of high integrity. Blockchain's technology three pillars include decentralization, transparency, and immutability. Blockchain is the novel business-to-business transaction network that is promising to fuel the next step change in the digital revolution. Don and Alex Tapskett may have said it best when they said, "The blockchain is an incorruptible digital ledger of economic transactions that can be programmed to record not just financial transactions, but virtually everything of value." This digital ledger is managed via a distributed network across many nodes that can verify and confirm those transactions through consensus. The implications of the technology are far-reaching, but there are conditions that should be met in order for blockchain to be a viable solution. Before implementing a blockchain, you first have to determine if the existing database is fundamentally secure across all endpoints, because if not, the system could be susceptible to tampering or alteration from internal and external forces. This would cause the loss of things like a trustless system, where trust is distributed across many stakeholders instead of concentrated in a single individual or entity, for example banks, governments, and financial institutions. You would also lose decentralization in your system, resulting in a relatively weak blockchain. If intermediaries, large middleman fees, or confirmation time delays play a key role in your database system, then blockchain would expedite this process, cutting down or even eliminating some costs for all users. The last factor to consider before implementing a blockchain solution is the interaction of transactions. If your transactions do rely on one another, determining how to distribute corresponding transactions amongst master nodes in a centralized system becomes quite difficult, resulting in the need for a blockchain. A blockchain would alter the collective state of the database by distributing those transactions. Once all of these conditions are met, you can then look at the possible use cases within your shared services organization to determine the viability of a blockchain. Service is anything which provides or delivers value to the customer. According to Rick Perrozet, by consolidating services and operations from different business divisions into a centralized center, a company can create a shared services organization. This can provide a cost-efficient front office and back office operations that are used by multiple divisions of the same company, which would eliminate redundancy. By providing a service in one place, there is an opportunity to optimize and standardize it at scale. He mentioned that today, most companies employ a shared services model for such services as accounting, human resources, payroll, IT, legal, compliance, purchasing, and security. By consolidating these services and providing them upon request, each business division can then focus its limited resources on activities that support the division's business goals. Shared services are the provision of a service by one part of an organization or group, where that service had previously been found in more than one part of the organization or group. Thus, the funding and resourcing of the service are shared, and the providing department effectively becomes an internal service provider. This figure depicts the interplay and sharing of organizational services as to the capacity and capability required of sharing. Human resources, for example, is service 2 in this figure, are utilized by all other services and department. This simply put into context that human resources do not only cover the recruitment and compensation and benefits, but it should manage all activities and functional spaces of an employee while he is employed in that organization. According to Rick Perrozet, the common application of blockchain in industries includes cross-border payment used for blockchain, human resources, accounting, and file integrity. Blockchain is frequently referred to as the Internet of Money Bitcoin. The first implementation of block technology is the preeminent cryptocurrency. Cryptocurrencies allow people to store their money securely and make payments without intermediaries such as banks. This renders money transfers and purchases much simpler, faster, and cheaper. Alright? So this simply means that blockchain provides great infrastructure for monetary systems to the many sectors of the economy, especially in the service management sector or the tertiary sector of the economy. He furthered that global corporations are looking for alternatives that will reduce their delays and their costs as well as increase reliability and accuracy. Blockchain provides a solution to overcome the current structural weaknesses by offering near-instant cross-border payments at lower costs, higher security, and more reliability. With blockchain, payments are tamper-proof and accurate, thereby trimming costs associated with investigation of cases and litigation. For multinational businesses, cross-border payment transactions present a host of delays and fees. According to McKinsey, cross-border payments offer $135 trillion in flows, bringing in $240 billion in revenue. The average transaction value is between $15,000 and $20,000, so that means corporate cross-border payments typically cost $30 to $40 per transaction. That's a high cost for a payment that involves multiple financial institutions that create a complex web of procedures resulting in delays and inaccuracies. In addition, there are accompanying fees and charges at each stage of the transaction. In the human resources, blockchain would give a competitive edge to organizations that recruit based on verifiable credentials to find candidates that are overlooked by other organizations that only focus on traditional education and resumes. From a hiring perspective, access to academic credentials and certifications could reduce the amount of time recruiters spend verifying information. A wealth of information about potential candidates could be stored on blockchain, making it easy for recruiters to find and verify everything from educational levels, postgraduate certifications, and accomplishments. Once a credential is recorded to the blockchain, it can't be changed, deleted, or faked. A fraudulent credential may look like an issued one, but it can be verified against the original blockchain record to confirm if it is valid or not. Digital credentials would remain secure, even if the company issuing them were to be hacked. Also, if schools or businesses shut down, a candidate's records would remain available. This means their records can be accessed no matter where in the world an individual decides to seek employment. The concept of a self-sovereign identity could become a reality on blockchain. Candidates could have complete control over the data of their professional and educational lives, providing access keys to potential employers when they apply for jobs. This could expedite the hiring process by including degrees, certifications, courses taken, grades, employment history, salary, and more. Every audit is a costly, labor-intensive exercise that ties up the company's accountants for long periods of time. The public auditors, who are hired by management to perform these audits, also have stakeholders who place their trust in their integrity in order to make decisions. This raises the issue of where does the auditor's accountability truly lie? Blockchain technology may solve for this accounting problem. As a source of trust, it can be extremely helpful in today's accounting structures. Instead of keeping separate records based on transaction receipts, companies can write their transactions directly into a joint register, creating an interlocking system of enduring accounting records. Since all entries are distributed and cryptographically sealed, falsifying or destroying them to conceal activity is practically impossible. It is similar to the transaction being verified by a notary, but instead done electronically. Diamonds are forever right, and so is blockchain diamonds. Works of art and other items of high value are among the first areas where blockchain projects are innovating to provide transparency, security, and trust. The last one, common application of blockchain in industries and on file integrity. Being able to prove the integrity of electronic files easily is yet another benefit of using blockchain. One way would be to create a digital fingerprint by generating a hash string of that file. That fingerprint is immutably time-stamped by writing it into the blockchain via transaction. This provides the ability to prove the integrity of that file at any subsequent future point in time by again generating the fingerprint and comparing it with the fingerprint stored in the blockchain. If the fingerprints are identical, then the document would remained unaltered since first writing the hash to the blockchain. According to successful implementations, Bank of America, and PepsiCo, to name a few, about shared services industry can utilize this technology to gain a competitive advantage by increasing its number of transactions, improving its efficiency and lowering its costs. Blockchain massively improves spending volume by enabling real-time settlement of transactions, identifies bottlenecks, and improves flow and visibility along the supply chain. Replaces paper trail with tamper-proof documentations. Reduces the risk of fraud and errors. Improves validation and authentication along the P2P chain. And finally, it increases visibility and transparency of business process. But the question is, how can a company or organization embark into becoming a smart industry utilizing blockchain into its shared services? And why use blockchain in shared services? We need to conduct organizational environmental scanning and embark planning for the future. Technology route mapping is a planning method which has been successfully applied to balance the short, medium, and long-term issues facing the business in terms of technological and product development and evolution. The map shows how current and future technological investments support future product development and delivery in the context of market trends and drivers and customer needs, linking to resource requirements and research and development programs. Foresight provides a means of supporting the medium to long-term inputs to the technology route mapping. Technology route mapping is primarily important at pre-departure to technology road mapping. Hence, applying blockchain in industries may or may not advocate Internet of Things. Technology road mapping is a flexible technique that is widely used within industry to support strategic and long-range planning. The approach provides a structured and often graphical means for exploring and communicating the relationships between evolving and developing markets, products, and technologies over time. A technology roadmap, also known as an IT roadmap, outlines the plan to reach short-term and long-term goals through the use of technology solutions. This type of roadmap typically provides key information which helps organizations make better decisions around technology investments. Technology road mapping facilitates the integration of new technology into the business, supports for company strategy and planning processes, identifies new business opportunities for exploiting technology, provide us top-level information on the technological direction of the business. Technology road mapping also supports communication and cooperation within the business, identifies gaps in market and technical knowledge, supports sourcing decisions, resource allocation, risk management and exploitation decisions, high-level integrated planning and control, and will serve as a common reference framework for technology and project management in the organization. But somehow, although it feels like should be talking about how to utilize it more in business services, it's still too easy to assume it doesn't really translate to industry day jobs, that is running shared service operations, and relegated it to the nice-to-know pile. And that was okay at first. But going forward, it's fast becoming clear that shared services professionals will need to adopt a very different attitude to the opportunities that blockchain represents to both the digital back and front offices, and pretty quickly, or risk being left behind. Generally, information technology service management refers to the entirety of activities directed by policies, organized and structured in processes and supporting procedures that are performed by an organization to design, plan, deliver, operate and control information technology services offered to customers. This figure presents the shared services management model. According to TCG, the SSMM provides a framework for agencies to think about and manage these capabilities for their own shared services. The SSMM guides agencies through the shared service resource development process and the activities that need to take place during program strategy, planning, project mobilization, oversight and monitoring, security, operations, and improvement phases. The key components of the shared services management model are shared services outreach including the lead management, customer discovery, onboarding new work, ongoing customer contact, surveys feedback, planning logistics improving, and branding marketing campaign events. On the management support component, this model allows organizations and industries to manage components such as program management office, MO, information assurance, shared services partner engagement, technology architecture and expertise, resource management, contracts administration, quality assurance, and finally, the technical support component, which includes the product integration, agile development and partnership with domain experts. Further, the shared services governance life cycle can be mobilized and managed with its program strategy, planning, project mobilization, oversight and monitoring, security, operational excellence, continuous improvement. Question: how can a company successfully plan and forecast its future business position using blockchain? We need planning, or we can use technology route mapping. Although there are many more shared services use cases that I could have highlighted, the ones presented provide a strong argument for how blockchain could provide maximum benefit to the corporate shared services organization. Everything from immutable records, to stamps, cost, labor and time reductions to automation are all possible with a blockchain solution. The real challenge may be getting your organization to adoption a blockchain solution in the operational and strategic workspaces in the organization, when to embark using technology road mapping.